Hello everyone. How's the energy level? Is it high, low? Should I talk really energetic or should I talk slow and monotonic so that you can zoom out for half an hour? Energetic, great. Okay, so as introduced, my name is Evaldas. Today I will talk about safety, data, and AI. A little bit about me. I currently am working as a lead data scientist at Vinted. Before I worked at several different Lithuanian startups. And it just so happened that I worked always with security as a data scientist. Either that was cybersecurity for internet, payment fraud, content moderations, or now I'm working with counterfeits or phishing. I never planned to work in security. It just so happened that these problems are difficult to tackle. So I'm the one trying to solve them at least a bit. All right, now let's talk about the topic. So there was a report from about e-commerce merchants that are spending. Could anyone guess what percentage of their revenue they lose every year fighting a fraud? Any guesses? 13%, half percent, 7. Well, that number is 3%. If you think about, the revenue, the thing that you're owning, and then you can spend on anything, you're basically just fighting a bad actors. And something that's related to Vinted is that, in 2023, just in European Union, we had a record year where we sized over 150 million fake items with an estimate worth of 3.4 billion. So the scope of problem big, and the first part about safety being non-negotiable, I think that is a checkpoint, right? But how do you deal with this? And this is what my talk is aimed for. So I identified 3 different stages of how you approach building safety tools. So first of all, you stumble upon the problem, then you start to use AI to solve it, and then you take a step back and look at the bigger picture. So now let's go through each stage individually. So the crawl stage. So let's say we have a hypothetical company that is growing at exceeding pace, and your stakeholders are happy, the revenue is growing, but then the holy trio looks at your metrics and they notice an alerting size of chargebacks. That holy trio is usually your chief financial officer who's really interested in the numbers, a product manager that is curious and just trying to understand how users are behaving, or a data analyst tackled to detect these kind of things. But it's usually never the intention initially to define a metric. And this is something that usually people tend to stumble upon almost accidentally. And the issue here is what's happening is that once your platform is attracting good users, you're also attracting bad actors. So you're basically suffering from success due to your reach. So how do you deal with this? So the initial start is always creating static rules, right? It always starts simple. If an order higher than X amount of euros, and this comes from particular country, we might block this kind of order. If there's a new account that buys more than X of the same items, maybe you want to trigger more extensive personality check via bank authorization. But then over time, it gets more complex than that. So you try to look at operating system, maybe device resolution, what kind of operating version it is running, and it gets complex more and more over time because the malicious actors tend to change their patterns quite actively. But the key benefits of rules are that they are simply to explain to others, to your stakeholders, to your colleagues, to yourself, even when you look at the rules like a couple months back. And they are also easy to create or modify them. However, when creating manual rules, you always put the effort on the manual work that an analyst do. And then to create more complex rules and identify more complex patterns, you usually tend to need to increase data collection. It's also prone to attacks happening after work hours. In my experience, I have seen in the past attacks that are starting Friday evening or Saturday morning, and then on Monday morning you come back to your workplace and see that, okay, we messed up during the weekend and we lost so much money. And they are easy to avoid after performing minimal adjustments. So let's say if you go to the initial rules, if an order with a certain amount, maybe you can find a discount code, maybe, try to do it cheaper. If it's a country, maybe you can use VPN to switch your country and mask your origin. So there's always ways how can you evade those rules. But you can also succeed at this stage. Not all systems require complex systems, and rules tend to work. And I've seen this in my experience. And to succeed at this stage, you have to build metrics that track malicious behavior. And not only create those metrics, but you have to actively monitor those business metrics. You also need to allocate at least part-time, some resources for data collection, from front end, back end, on what kind of data we can gather about the user behavior. And then testing on historical data, so something that you can perform offline validation on your rules. It increases your confidence when pushing new rules to production. And real-time monitoring allows you to identify problems fast and mitigate them, as they are occurring, and not to be playing catch up. Right. But sometimes, rules are not sufficient enough. The malicious behavior is persistent, and they are actively trying to break your rules and evade the detection. So the natural thing is to use AI. Everyone is using AI. Everyone is talking about AI. Your investors probably are asking you why you're not using AI. So this seems like a good application to use artificial intelligence. And hopefully by this time you manage to do your homework for data science to succeed. So you already have some historical data that you can use for training. You have clear business rules, so you can define this as an objective for your machine learning models to optimize. And then you can use rules that you did before to use them as a feature engineering to share this expert knowledge that you built over the course of several months to hopefully improve your machine learning models. And when compared with rules, there's quite a few benefits, as machine learning models tend to capture more complex patterns better. They can potentially block future attacks without prior knowledge. That requires a really good generalization from model, but it is doable if you train your models well enough and you have enough data. It can work with more complex data. So, if you are talking about transactions, they are usually tabular, but what do you do with text or images? And yeah, it kind of requires less human effort because, well, you can allocate one data scientist to solve this problem and they will sit down for a couple of months tinkering and maybe, able to produce a model that is better than several analysts working on a static rules. However, there's quite a few drawbacks and mostly regarding the scale of the problem. So you need data for your model to generalize well. It does not generalize with a couple examples, and you usually, to generalize well, you have to have like a major attack that you can then use in your training data set to learn, to train your model better. It's also difficult to train machine learning models because due to scale of class imbalance. So you think about, fraudulent transactions, usually like 99% of the transactions are good, and that 1% is from malicious actors. How do you force your model to make better predictions on that 1% that, if you measure on accuracy, you get like 99% accuracy if you classify everything as good. It's also difficult to interpret how AI models work. So if you're using tabular models, so gradient boosted trees, they are usually interpretable, but it's not as simple as using the static rules. In my experience, I noticed that even if you are training a machine learning model with newer data, it not always leads to improvement. So it requires proper testing. And if your model has some kind of bias, it's probably going to be amplified to your users and could lead to some actions that you're not want to perform. And to succeed at this particular stage, you should spend less time modeling and improving your data set. I know that scientists are most excited about modeling. I'm also excited most about that part. But usually working on your data set quality is what leads to best gains for your training or machine learning model. And the closer your training objectives align to your business goals, the higher chances for you is to succeed. So as data scientists, we are obsessed with accuracy, precision, recall, and F1 score. But if you think, from your business stakeholders' perspective, they don't care about these metrics. They are outputs for you to understand how your model behaves, but your business stakeholders care about what kind of improvements on a business metrics that you can make. And I would also recommend to invest time to setting up auto retraining pipelines with strong offline evaluation. So I would put an emphasis on strong offline evaluation because it's easy to set up auto retraining because bigger technology companies have running scheduled pipelines automatically. You can set it up them quite easily. But thinking about how to properly evaluate your model and how it's gonna behave potentially in production is a key. Uh, it helps to ease your mind on releasing new model versions. And one common issue that I notice with data scientists is that in scientific literature, a most common way to split your training data is to randomly split it into sections. But actually, I would argue that this is a bad behavior, and I strongly advise not to use it. And the only approach to do it is to split it time-wise, because by splitting randomly, you're basically introducing future attacks in your training data set. So it's going to perform better on the evaluation part. While if you split time-wise, you get worse offline evaluation metrics, but potentially better generalization of your model and better performance on production in production setting. Cool. Now we covered the first two stages. Let's proceed to the stage 3, run. But before talking about, what kind of improvements you can do in the stage, let's take a look where are we now. So coming back to our original problem statement, example where we are talking about fraudulent transactions. Let's imagine our user workflow. So our user visits a website, right? Browses your portal, then maybe perform some kind of search queries, views several items, maybe chooses one of them, adds to cart, and then makes a purchase. At the purchase stage, your model is making a prediction. Is this a fraudulent transaction or is it a good one? However, your user behaved on your portal or your website quite a bit, but you're not incorporating that information in the purchase evaluation. And if you think about, user behavior timeline, like a video, at the purchase stage, you're taking like a single scene out of a movie to make your predictions of is the user malicious or not, but you're not taking the whole movie into account. And how can we approach this? Well, if you're working in a large organization, you'll most likely have several other teams that try to optimize some different objectives using uh, recommendations, search, and they are probably also employing machine learning models to do that. So maybe we can talk with them what they are using, and maybe we can actually use their features. So there's a couple of feature ideas, from search or recommendations, like a search session count, time between searches. From recommendations, maybe average time on product page, how much time it takes for a user to add an item to a cart, are users interacting with recommendation widgets, and those features are designated for search or recommendation intention, but it also captures the user behavior on your platform. And maybe you can, share those features and hopefully improve your current fraud detection model better. And the best way to share this data is is a system called feature stores. So I saw that yesterday there was a talk about feature stores, so I will not go into details of what it is. But it's basically a database where it allows other teams to share features, and a feature store usually has two purposes. So for online retrieval, so for your production environments, you get you calculate feature, and then your model immediately can use it during the inference. And then for offline retrieval, so when you want to check for a feature for user X at this given point in time, what was the value of that particular feature? And now that you're augmenting your model with features coming from different departments, you're usually not that aware when those features start drifting. And feature drift is when the feature distribution changes over time from the initial one that you use during the training versus the current one that is happening in the production. And the issue is here that with the feature drift, your model expects certain distribution in your features to make accurate predictions, and when those changes, your model output also becomes a little bit more undeterministic. So it's worth to look at the data drift and track it. And now that you've built some methods to do that, I would also recommend to perform concept drift. So if data drift is focused on the feature distribution change, the concept drift looks at your model outputs and how that distribution changes over time. Are your models making consistent predictions throughout a month or even longer periods, or you seem that the predictions of your models start to deviate from the ones that you expected? And this helps you to understand, are your model behaving the same or differently when it was initially trained? Just to recap, so at this stage, feature store is how you squeeze out the last drops for your model performance. When you detect data and concept drift, it allows you to immediately retrain your models and hopefully mitigate any potential risks before those happen. If in stage 2, automated retraining, it was mostly scheduled on, let's say, bi-weekly or a monthly stage. Now we can be more proactive when we notice any not expected behavior from your model to immediately retrain it and hopefully improve the situation. And I guess I put also emphasis on the cross-functional collaboration because there's usually several different teams in your company that doing machine learning. So maybe collaborating on the features is how you can take a step back and have this bigger picture on the user behavior throughout your platform instead of having this narrow focus on one specific flow stage. And I guess I would like to put an emphasis on the success story. So Stripe, I totally recommend read this annual letter from 2024 from Stripe. And they built such a high quality system there that based on their data, they can see at which hour malicious actors are taking lunch breaks. So they see the increasing patterns, then they stop for an hour, and then they continue for the second half of the day. And the success story here is that they managed to decrease card testing attempts by 80% over 2 years, and that is a significant change for them. But they are at this final third stage where they identify that it's not sufficient enough to have like a single strong signal that you can you identify a malicious user behavior, but you actually have to have thousands of small signals that you aggregate them and then be able to make really accurate predictions. And now the stage 4. Does anyone have any ideas what could be at stage 4? Well, given the current trends, maybe it could be multimodal large language models, Reasoning is a big topic of reinforcement learning, federated learning for privacy, graph-based methods, zero knowledge proofs. To be honest, my manager is asking me about this because I'm a lead data scientist, but I actually have no idea. And I welcome you to join me and discover this together. So just a short promo, Vinted is hiring. We are hiring for different positions. And our mission is make secondhand first choice worldwide. And we are succeeding in it and we are scaling big. So come to this journey and let's solve this issue together. And thank you. That's it for my talk. I will gladly answer your questions if you have any.
Any questions?
Hi, thanks. Winted is not available in Latvia. Have you excluded us in, stage 1? X items from Y country?
I would say soon. So tell her that Vinted please said soon.
Thank you. You said for the second stage, you recommended spending more time on improving data quality as opposed to advanced models. Could you talk a little bit about, are there any like the overarching themes in data quality that you've noticed when it's like coming from the data that you're using to look out for?
Yeah, there's couple things. I would say the data leakage. So for example, some features are calculated after you're making a purchase, but people tend to include that in their training data set. So it's basically leaks, that information. Then there is a problem with some feature calculations. For example, you have this really good feature that's really valuable to our model, but maybe that feature calculation takes like 5 minutes of browsing, right? And then if you have a user that makes a purchase in like 2 minutes from just going to your portal, then you probably don't want to have that feature, right? So you have to take into account how feasible it is for you to retrieve that feature. And I guess the data leakage, the most common one that a lot of people are yelling, "Oh, we managed to achieve such a real good results." If the results looks too good, you probably mess up somewhere, and you have to revisit what you did and find the issue.
Yeah, so basically, I imagine that rules are still like necessary, probably like in combination with ML models and whatever. I don't know, just a wild idea. Maybe it's possible to use, AI to come up with new rules. So just a wild idea.
Yeah, it is viable, but I would recommend to use heuristics approach, meaning that you define some kind of optimization objective, and then you just run wild calculations in cloud that try to find or satisfies that objective or to minimize some kind of score like false positives or something. So it's doable, but I would define this problem as an optimization problem and do a heuristics based approach.
If there are no more questions, I would like to say thank you. And yeah, thank you for your talk.